Hey everybody, Lars here. Time for the third review video for Big Bad Unit 3. I just started brewing some coffee, so probably in the middle of this video I'm going to go up and get some, so don't be surprised. Also, I did a bunch of things to the microphone, so I hope that sound is coming through okay. Boom, 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 pop your peas. But as usual, I digress. Notice the beard? I had to trim it yesterday. I had to go do something yesterday, and I didn't want to look like a homeless person. It was okay to look like a homeless person in front of you on Tuesday night, but apparently it's not okay to look like a homeless person when you do other things, but that's okay. Tonight, we're going to do two things. First thing we're going to do is I'm going to show you some stuff about libraries, and it's not really third-party libraries yet. If you've read the slides, we're going to deal with some stuff in standard libraries like the math library and statistics library. And you'll see what's going on when we get there. Plus, I want to show you how to create your own libraries. But when we do that, we're going to do something completely different. And I'm going to start from scratch and do a little homework assignment of my very own. And hopefully that will get you started when it comes to your homework assignment, which you're going to get tomorrow evening. I'm recording this. It is 10:22 p.m. Thursday night. I ran into a whole bunch of things yesterday, so I wasn't able to do this video, but I'm doing it tonight. Then tomorrow I'll release the assignments. Then over the weekend, I'll do that promised extra video where I rewrite Euler 6 using everything we know about libraries and functions and all the cool stuff that we've learned since then. All right, so let's get going. First thing I want to do, we're going to start from scratch, basically, with a whole bunch of stuff today. So I'm going to say new file, and I'm going to run up here. And I'm going to give myself some comments because that's how I roll. And then I'm just going to say something simple, the list, and give myself some numbers. Now, let's say I want to print the sum of the list. So I do that. It's going to ask me to save. So I am going to go to Python for Data Science. I'm going to jump down to Summer 2017, Unit 3, and I'm going to call this lib stuff. And some lib stuff is going to go up on Sakai when we're done with this. So now I save and I run, and I get 29, and I'm assuming that's correct. Let's see. This is right. Yes, it is. Beautiful. Now, let's say, put these together, that I want to, I can smell that coffee. It's hazelnut. I usually get the whatchamacallit, French vanilla, but I'm making hazelnut this time. And it is hot. My God, it's so humid. Alexa, what's the weather like?
In Watuchin, it's 83 degrees with clear skies. Tonight, you can look for lots of clouds with showers, with a low of 71 degrees.
Okay, I didn't hear showers. 80-something degrees, though, at 10 o'clock at night. It's muggy, too. All right, I'm sorry. Let's continue with the Python. So, I do the list. I get 29. That's a good thing. Somewhere, I don't know where, I heard that you can get the square root of something. So let's do this. Let's say A equals the sum of the list. So this way, when I print A, I should get 29. Let's see what happens. All right, so I'm still getting 29. I just took a fruitful function, sum, and I assigned it to a variable, and then I printed the variable. All right, so we're in Fat City. Now, let's create a variable called B, and I want B to be the square root of A. Okay, so 29. Here, you want to make our lives easy? Let's make our lives easy. Get rid of that 4. So now B is going to be the square root of A. So I rerun my code, and I get an error. And we can see down here, name, sqrt, square root is not defined. Not defined. I wonder what's going on here. What I happen to know, because I'm a Python programmer, is that square root is indeed a function that we can use. But square root is a function that resides in the math library. So I'm going to come up here, and I'm going to type import, and you can see lovely idle turns it orange because it is a keyword. And I'm going to say math. So now, if I come down here and I say, hey, Python, go to the math library and then look for square root. Oh, look at lovely idle. It will actually come and tell me what all the different functions are that I could use in that library. So now I'm going to print B. Wasn't even printing it before. Kind of knew it would blow up. All right, so now if I run that, what do I get? Da, 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 and you can see that square root returns a float, because I get a float for the answer. Okay? Now, you might be saying to yourself, well, how am I supposed to know what's in math, and what's in this, and what's in that? You know, this is what you do. You go to, I'll tell you the Camtasia story. I'll tell you the Camtasia story later. I'm sitting here looking at reviews. I'll tell you that story. Come here, Python, docs, standard library. Look at that. Look at Google getting things ready for me. Dun, 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 dun. The Python standard library. Okay, all online. Instruction manual is online. You can look at built-in types and built-in functions and all those things we talked about in the first part of this unit, but you can also look at all of the libraries. Okay, here's our friend math. Bing. And you could look up all of the different functions that are available for you to use. Newsflash. We learned the basics of Python, okay? We know how to iterate. We know how to do functions. We know how to do simple data. We know if then, blah, blah, blah. Now you can see all of the different functions that people have already written. The people who brought you Python have already written for you to use. It's sitting out there. If it's simple and it's handy, trust me, someone wrote it already. And it's sitting out there in the libraries. Go to the standard library pages and take a look at all of these different things. Factorial, there's floor and ceiling. We'll play around with floor and ceiling. But I want to look for square root right there. Okay? All in the documentation. So check that out. If I wanted to, I could say C equals, well, you know what? I'm going to go back and make the list funky again. So watch this. Watch me work. Now if I run it, woo, I get something crazy for the square root because it's floating point and it's got pretty decent precision. But let's say I just wanted that to be a 5, right? I'm going to make C equal to math dot floor of B. And I'm going to print C. And then when we do that, you see I get a regular 5 because I did a floor. But I could also, here, let me save some time. Not saving time talking about it, but if I just do that, I can say let D equal to, or assignment, excuse me, seal. Is that the right way to spell it? I think so. And then I'll print C, comma D. And we're good. Say 5 and then 6. So you can see, as far as rounding is concerned, we have a floor, we have a ceiling, everything is good. Now, we don't have to just stick with the math library. Let's look at statistics. And we'll say here at the end, just for S and G, we'll say print math. I was about to say math. Statistics dot mean of the list. And you can see the mean is 5.8. Okay? Mean, standard deviation, all that different stuff. I don't have to do that. I can show you. Statistics right here. Boom. Look at that. Mean, harmonic mean, median, mode, standard deviation, variance, all of those wonderful frequentist statistics that you love. Egon, Pearson, Fisher. All right. So, there's one more thing I want to show you. And that is, you can see I import the math library, I import statistics, and then I tell Python where to go and grab them. But if I didn't want to do that, if I just wanted to use the function square root or floor or ceiling, I could do this. I could rewrite this. Let me put that down there. And say from math, import square root, ceiling, and floor. And then I will say from statistics, import mean. Now, if I run this, it's going to blow up. I'm pretty sure it's going to blow up. And it does. Because now I've associated these function calls with that library. So I don't want this in front anymore. I just want to make these calls without the library in front because I've pretty much tied them up there to that library. Now, when I run this, it should be okay. And I am. I'm back in business getting what I'm used to getting. But to be quite honest with you, I want to show you how to do this because I want to be complete. But to be completely honest, I don't like it. And I usually, when I program, do not do things this way. I import math, I import statistics, and then when I'm in the code, I tell people what library I'm going to. Because one of the big things in Python is readability. And if you're reading this code, I want you to know where I'm going. Oh, thank you, Idle. How nice of you. I want you to know where I'm going to get this particular function. It's not homegrown. It's not something I did myself. It's not something I'm reading in from some custom library. We're going to look at that in a minute. No, this is from the statistics library. This is from the math library. So that's basically the way I do it. All right, let's run this one more time. Make sure we're back to normal, and we are back to normal. Okay, I'm going to stick this code. Let me just put something up here. Playing with libraries. Good enough. And I'm going to stick this up in Sakai for you, but there is one last thing I want to do. And do I need that? Yeah, yes and no. All right. I am looking at Windows Explorer. Those are all the bike rides that I go on. And I'm going to go to the directory where I keep my Python, called Python 34. Because I have a 3.4. There's my Python 2.7. Don't tell anybody. But I actually use 2.7 too. All right. If you go to wherever your Python installation is, and I know Windows 10 puts it in a funny place under the user directory, and other systems, Macs, put it in a funny place. I know I did this on a Windows 8.1, and I did it in a custom directory because I know where to put stuff. So I came here and I put it in Python 3.4. If I go to the capital LIB directory, okay, and I go down here, these are all the libraries. So if I want to see statistics, where are you? It's right there. So I can double click on it and I can actually look at the code. Okay? A lot of comments in there, but after a while, you're going to understand all of this. You know what? You probably understand 80% of it now if you go in here and take a look. I don't want to freak you out with dictionaries and some other of the nutty stuff that they do with templates and stuff like that, but here's the code. If you ever want to go look at the code, it's sitting here in the library, okay? So you can look at statistics. You can look at a whole slew. When you come here to the library and you look at all the things, data compression, persistence, file formats, operating system services. We're actually going to look at that in a second. Internet data handling like curl and grabbing data off the web. Things like that, protocol, support, HTTP. If you learn about something called sockets, you're going to learn about that. Multimedia services, all of this stuff is already written for you. Read about it. Check it out. Look, Google things when you see other people's code and find out iteration tools. Might be good for Project Euler things. ITER tools is big. All right. But there's a little something here that I want to make you aware of. Hey, there's the statistics library. I double click it. I can look it up. I can see how all of these different things are written. There's p-variance. There's variance. Look at that. How neat. There's mode. I can actually see how these things are coded. That's great. All right, let's go look at the math library. And numbers. And there's math isn't there. Okay? There's actually math isn't there. Let's go look for sys. That's the one that lets you do all of the different kinds of things with the there's a group of libraries that are not in this particular directory. Remember how sum was a built-in function and int and string are built-in functions? There are certain libraries that are called built-in modules. and it gets a little hairy and it gets into the weeds, but it's because Python was originally implemented with C, and some of the C libraries were so easy to just use as is that they kind of just got built into the system. So when you use math, you're actually using the C math library, and it's in a already object code codified DLL kind of file that you can't read. Sometimes you can read them, sometimes you can't. That's a term, that's a little artsy fartsy. But if you wanted to see what those were, you come here to your interactive window and you type import sys, look it up if you want to see what it is, and then type sys, test my memory, built-in module names. Yeah, but it's an underscore. I don't think it's a dunder. I think it's just one. We're going to find out, because I got no problem making some mistakes if I have to. Sys built-in underscore module names. Correct? Ha-ha! Got it right the first time. You can see there's a list that, well, it's not really a list if you look at the parentheses and not the thing. I digress. But you can see in strings all of the libraries that are built-in modules are there. And if we come down here, we can see math. And if you come over here, you can see sys. Okay? Time is one of them too. So there's a lot of things that are basically use C back in libraries. I don't want to tell you that these libraries reside in the lib directory and then you go there looking for a library and you can't find it. You might be looking for a built-in. And if it is a built-in, it'll appear in this list. And you have this now because I did that. I did it here in the video so you can come back and look. Iteration tools is there. Error, yeah, I mean, you if you know C, you'll look at all of this stuff and you'll say, oh, that kind of makes sense. Okay? All right, good. Now, let's switch gears. I am going to, as I promised, what's that doing there? As I promised, I am going to take this code and I'm going to put it in your resources so you will have it and you will be able to have fun with it. This video is going to go long, huh? What am I looking at timing-wise? Why doesn't it show me? 18 minutes. 18 minutes. Jeez Louise. I should actually make these two separate videos. Should I? Nah, screw it. I'll do it quick. All right, let me get rid of this. And now what I'm going to do is I am going to... Should I do another video? How much time is this? 18 minutes? Yeah, you know what? This went long enough. I will end this video, and I will not do any announcements, because you're going to get another one. But you know what? This makes perfect sense, and I'm glad I'm going to do it this way. I'm going to kill this video here, and then I'm going to start it up again and do a fourth video, but this time I'll do it with my coffee, because I think my coffee is done, and it smells really good, so I got to go get some. And then I can come back and do my little homework assignment, and then it's two different videos. Then this part, which you probably are going to watch once or maybe 1.5 times, you don't have to worry about. But the homework one, I know damn well you're going to watch 3 or 4 times. So I will do that separately. All right, then I'm getting out of here, and I'll be back in 10 minutes, all right? But that's could be longer or shorter for you, depending on when you watch the second video. I'll talk to you soon. Goodbye.